In this three-dimensional problem, we're given a current element dl directed along the y-axis in this direction, and we're asked to find the magnetic field produced by it at a point along the negative x-axis and the positive z-axis. It's located by the position vector r equals xi hat plus zk hat. We can use the right-hand rule, placing our thumb in the direction of the current element and curling our fingers in the direction of the field, to find that this magnetic field has components in the positive x direction and positive z direction. But to find the magnitudes, we'll need to use the Biot-Savart law. I'll write that here. And to make evaluating this a little easier, I'll rewrite the r hat vector as the r vector divided by its magnitude so that we get this expression. We can calculate the value of r cubed using the Pythagorean theorem and then cubing that result to find that r cubed equals 0.567 cubic meters. And we can evaluate the cross product dl cross the vector r by finding the determinant of this matrix. The vector dl has a y component, and the vector r has x and z components. This gives us a cross product of z dl I hat minus x dl k hat. We can factor out the magnitude of dl to get this expression, and then return to the left, substituting these results into the Biot-Savart law. We have mu naught over 4 pi, which is 10 to the minus 7 Tesla meters per amp, multiplied by the current I, times the cross product, the magnitude of dl, which is half a millimeter, times z I hat minus x k hat, and divide all of that by r cubed. When you calculate, you find this value for the magnetic field. As we expected from the right-hand rule, it has components in the positive x direction and the positive z direction.